Reference angles and coterminal angles. We're going to start with a definition for the reference angle. The reference angle is a positive acute angle. So remember, acute angle means between 0 and 90 degrees. That can represent any angle of measure. The reference angle is always the smallest angle that you can make from the terminal side of an angle, so where the angle ends, if you remember back to our standard angles, with the x-axis. So let's actually look at some visuals. I have this broken down into 4 different quadrants. So let's start with the first quadrant. It says that the reference angle has to be positive. So regardless of if we are measuring clockwise or counterclockwise, remember clockwise would be our negative measure. If we're counting clockwise, our reference angle will still be positive, and I'll show you an example of that later. The reference angle is the angle that is made with the closest x-axis. So the red part here that I'm now highlighting with blue is the reference angle. So in the first quadrant, the terminal side and the reference side create the same measure of angle. Whereas in the second quadrant, we have the angle that starts in standard position, and the reference angle is only the distance between the terminal side and the closest x-axis. The third quadrant, again, our angle is in standard position. It would rotate all the way to the third quadrant, but the reference angle is only measured between the closest x-axis and the terminal side. For the fourth quadrant, this angle is in standard position, and we only have the reference angle from the terminal side to the closest x-axis. So let's actually do some examples. So for example 1, find the reference angle for the following. So the first one is 235 degrees. So I'm going to start by creating a visual. I'll start with a visual. So we have 0, 90, 180, 270, and 360. And we're just going to estimate 235 will be in quadrant 3. So I'm going to draw my angle in standard position. Now to find the reference angle, remember the reference angle is the distance between the terminal side and the closest x. So we can take 235, which is our standard, and we can subtract 180 degrees. And what we're left with is our reference angle, which is 55 degrees. So if you're given a problem that tells you that we have a reference angle of 55 degrees and it's in the third quadrant, you should be able to calculate the actual angle in standard position. For the next question, we'll start by drawing our graph. Now notice 2 things. We have radians, and it's negative. So that means we have to go clockwise with our rotation. So if we start at 0, we have negative pi over 2, which is equivalent to 90 degrees. We have negative pi, which is equivalent to 180 or negative 180 degrees, and negative 3 pi over 2, which is negative 270, and negative 2 pi. So if we're going to graph negative 5 pi over 4, what I like to do is break down the fraction. We can look at negative pi is equivalent to negative 4 pi over 4. If you look at our fraction that we're given, we have negative 4 pi over 4 minus 1 pi over 4, and that is equivalent to our question, which is negative 5 pi over 4. So if we rotate negative 4 pi over 4. That will bring us to that negative x-axis, and then we just have to rotate a little bit further. We have to rotate another pi over 4 in the negative direction. And remember, pi over 4 is equivalent to 45 degrees. So our standard form is negative 5 pi over 4. But our reference angle is pi over 4. So yes, we rotated another negative pi over 4, but remember your definition of reference angle. The definition states that it has to be an acute angle and it has to be positive. So we convert that negative pi over 4 and we name it as positive pi over 4. Pause the video right now and try C and D on your own. Then I will show you the answers so you can check your work. Now let's go through these examples and see how you did. The first one is 420, so we draw our graph, we label it in degrees, we draw our angle in standard position, which is the blue line. Our reference angle is the pink, which is between the x-axis and the terminal side. The x-axis has a degree of 360 because we've done one rotation. 420 minus 360 is equal to a reference angle of 60. For D, we have radians. So we draw our x and y axis. We label with 0, pi over 2, pi, and 3 pi over 2. We break down 13 pi over 6, keeping that denominator the same. So 2 pi is equivalent to 12 pi over 6. 13 pi over 6 is larger than 12 pi over 6, so I did my fraction breakdown over here. So the graph rotates, or the angle rotates 12 pi over 6, and then our reference angle is another pi over 6. So you can do this fraction breakdown, or you could also take that 13 pi over 6 and subtract the closest x-axis. 12 pi over 6, you get the same answer. Whichever strategy works best for you. Coterminal angles. Coterminal angles are angles who share the same initial side and terminal sides. Finding coterminal angles is simple as adding or subtracting 360 or 2 pi from an angle, depending on whether the angle is given in degrees or radians. So what we're saying is that you can be given an angle and it has coterminal angles, which means that you take that original terminal side and you just add or subtract multiples of one full rotation. Then every single time, visually, the terminal side would look like it's lying in the exact same spot, and yet it has a different angle. Let's look at some examples. Identify 2 positive and 2 negative angles that are coterminal with the given angle. So we'll start with 305 degrees and we'll graph that first. There's my angle. To find a positive coterminal angle, we're going to take this terminal side and we are going to rotate it around one additional time. And then we want it to land in the exact same side, coterminal. The terminal side is identical to the original terminal side. So we will take 305 and we will add one full rotation. So we end up getting 665. Now for our second positive, we will take that original 305 and we will do 2 rotations. 1, 2. So we have 305 plus 2 rotations of 360. So there's our 2 positive coterminal angles. Now let's do the negative. We take that original 305 and we rotate it clockwise. 305 minus 360 brings us negative 55 degrees. And if we need another negative, we can do 1 rotation, 2 rotations in the negative direction. So 305 minus 2 times 360, which is negative 415. Now let's move on to, here is our graph of 5 pi over 3. We will start with our positive coterminal angle. So we start at that terminal side and we rotate 360 degrees. So 5 pi over 3 plus 2 pi. So 2 pi, if we want to have the same denominator, multiply this by 3 over 3. So 2 pi is equivalent to 6 pi over 3. So I'm just going to change this to be 6 pi over 3. And we end up getting 11 pi over 3. That's our first positive coterminal angle. If we rotate 2 rotations of 2 pi, we start with that 5 pi over 3. 2 times 6 pi over 3. We simplify, so we get 12 pi over 3. Add the numerators, keep the denominator the same, so 17 pi over 3. Now let's do our negative coterminal angles. We rotate in the clockwise direction, 5 pi over 3 minus 6 pi over 3. Remember, 6 pi over 3 is equivalent to 2 pi, which is 1 rotation. So we end up getting negative pi over 3. And if we rotate twice, 2 rotations, we have 5 pi over 3 minus 2 times 6 pi over 3, which is equal to 5 pi over 3 minus 12 pi over 3, which is negative 7 pi over 3. So a really quick reminder that the reason that we're using 6 pi over 3 is that it's equivalent to 2 pi, and 2 pi is 1 rotation, which is equivalent to 360 degrees.